Let's think about functions. When I talk about functions, I'm talking about a relationship between two sets. We usually call the first set the domain, and that's a set of input values. And the second set we call the range, a set of output values. And a function is any relationship between those two sets that assigns each element of the domain to exactly one element of the range. And we're probably very used to functions like this one that turn a real number in the domain into a different real number in the range. And in fact, we could write down the domain of this as all real numbers, plug in anything I want, no restrictions, and we know we're going to get out all of the real numbers from -1 to infinity, right? Because we're familiar with this graph. I want to introduce some notation that what this function is really doing is taking a real number and turning it into a different real number. And we could in fact write this smaller range here, but I'm going to just imagine this notation as meaning I'm taking a real number and turning it into a different real number, right? And that's just what the functions we're used to that operate on real numbers do. In our last unit, we were talking about vector valued functions, where vector r of t was equal to x of t I plus some y of t j, where x of t, y of t, and z of t were scalar functions, right, that were giving me a vector in space. And I could think of that as a function that's taking a real number t, right, because my parameter is just some real number in some interval, and turning it into a vector that points at a point not in R, but in R3. And then we saw curves in space and things like that. So we've already kind of expanded our notion of function. In this unit, what I want to think about is what happens if instead of letting the sets that are in my domain be in the real numbers, I let them be in the plane. So let's start with something familiar. So this is an introduction to functions on several variables. What I want to start with is the idea of a function on two variables. So let's just take something we're familiar with. Let's look at a sphere centered at the origin of radius 3. X squared plus y squared plus z squared equals 9. And let's get z by itself. So take the x squared and the y squared away from both sides, and I'm looking at z squared is equal to 9 minus x squared minus y squared, and now I need to take a square root. And I end up with z could equal one of these two equations. And just because I feel like it, I want to just think about the positive values of z. And I get this equation. Z is equal to the square root of 9 minus x squared minus y squared. And what I'm thinking now is anytime I was to plug in both an x and a y, I would get out a z. And since I was thinking about this as a sphere in space, I can also think of that as anytime I put in a point in the xy plane, I can get out a height. So thinking of the xy plane as a domain, I'd get out the height of the top half of the sphere over that point. So let's see. This was the equation of a sphere. I let the z's be bigger than equal 0. Yeah, definitely the top half. So let's see if I can sketch that. If I draw a sphere, it would look something like this. But I took the z's that were positive. So just the top half. There's my z-axis, an x-axis, a y-axis, and that's all I need. I plug in a spot in the xy plane and I get out the height above the xy plane. I get out the height on that sphere. So I think this is a function. I could think of this as f of x comma y, because I need to put in both an x and a y. And what do I get out? I get a real number z that I can think about as the height of the point over the point in the plane on that sphere. This is a function that takes a point in the real plane and turns it into a single real number. This is a map from the plane to just one real dimension. Well, let's think about the domain. Let's find the domain and range of this function. Well, the domain should be some set of x comma y's in the real plane, and I'm looking for x comma y's that I can use to evaluate that function. So since I have a square root involved and I'm going to limit myself to having real valued functions, 9 minus x squared minus y squared is going to have to be bigger than or equal to 0. I can add the x squared and the y squared to both sides of that inequality. And I end up with the inequality x squared plus y squared is less than or equal to 9. I like reading inequalities from left to right rather than right to left, so I swap that around. So here's my domain. All of the points that are less than or equal to, x squared plus y squared, they're less than or equal to 9. Well, if I think about x squared plus y squared equals 9, that's a circle centered at the origin with a radius of 3. Turning it into an inequality, I need to shade the inside to have all the points where I'd get x squared plus y squared is less than or equal to 9. So there's my domain. My domain for a function with two variables will be some set of points in the plane. I can't say things like all real numbers. I can't say things like open or closed intervals. I have to give a set of points in space. So here I've drawn them out. If I wanted to write this down as a set, I would tell you these are all of the x comma y's, all the x comma y's such that x squared plus y squared is less than or equal to 9. And I write that set down in what we call set builder notation. I'm looking for ordered pairs, x comma y. This vertical line is always read as the word such that, and then, then the rule I need to follow for x and y. X squared plus y squared has to be less than or equal to 9. The range, those values I can get out, well, if I think about what this function is doing, it's giving me the top half of a sphere. So if I imagine that, well, I know exactly what's going on. The lowest point I see in the sphere is at z equals 0, and the highest point's right there at the North Pole at z equals 3. So the range is a closed interval from 0 to 3. I can think about what's going on here a little more three-dimensionally by thinking about an x-axis and a y-axis like that, and then actually having a sphere to lay, a hemisphere to lay on top of it. The lowest z value is on the xy plane, and then the highest I go up is here at the North Pole, where z would be equal to 3. All right, so that's the idea of a function on two variables. We found a domain and a range, and we'll have several more examples after this.